TOGAF ADM perspective of implementing quantum computing in enterprise. So our group consists of Ainun, Alvina, Shindy, Shinta, and me. And today we'll start our presentation by going through the background of TOGAF ADM and quantum computing, followed by going through the research question and gaps of our paper, and we also have an analysis of implementing quantum computing based on the 10 steps in TOGAF ADM. So in 1965, Gordon Moore, which was or is the co-founder of Intel, predicted that the computational power will double up every 18 months, which was true back then, but not quite right now because the computational power has almost reaching its limit, and therefore a lot of researchers are trying to find out what are the alternative solutions to increase the current computational power. And quantum computing is one of the answers to it. But what is quantum computing? Quantum computing is a new computational technology based on the principles of quantum mechanics. And it's starting to gain attention from companies like car vehicle manufacturing companies are using it to calculate complex chemical calculations in developing the electric vehicle batteries. It also said that quantum computing can be used to crack complex equations like the 20488 RSA equation within 10 seconds, which would have taken a classical computing 300 trillion years to crack. Despite all the advantages and promises of quantum computing comes with its own challenges, such as it is susceptible to disturbance, whereby any changes in temperatures, movement, or straight electromagnetic wave would disrupt the accuracy of quantum computing. And also, it is already costly to implement because its hardware, software is not easily acquirable, and it also requires a dedicated cooling system in order to maintain its operation. So on the other hand, we like to talk about TOGAF, which is the method or the framework in develop, maintain, and deploy enterprise architecture in the organization. And based on TOGAF, ADM, which is the architecture development method, is built on top of TOGAF to define what are the steps in maintaining the life cycle of enterprise architecture to address the business strategies. But what are the 10 steps within TOGAF ADM? It will be explained by my colleagues in the next section. So now I'd like to pass the stage to Amina to talk about research and question.
So, many research have been conducted to guide enterprises for QC implementation. Some of the research focus on the technical consideration only, and the others focus on the business consideration. There is still lack of comprehensive research which can guide enterprises to implement QC with both technical and business consideration. Meanwhile, TOGAF ADM is a structured approach that can address this problem because it can provide both technical consideration and business consideration. However, as a generic framework, TOGAF ADM lacks of specific guidance for its application. There have been many attempts to adopt TOGAF ADM for different technology applications, but to date there is no research on how TOGAF can be used for QC implementation in enterprises. Building on these gaps, we were proposing a research question of what are the considerations when integrating QC into enterprise architecture based on the TOGAF ADM framework. To answer this question, we are providing analysis of consideration based on its phase in TOGAF ADM. Starting with the first part, which is the strategy and motivation, which comprise of preliminary and architecture vision. The first part, the preliminary phase, is to understand the organization. Two important points that enterprises need to consider is the first, dependencies of different aspects in organization. Enterprises need to understand how entities, processes, communication channels, policies, and compliance requirements are interacting with each other and also depending with each other. And the second thing that enterprise need to consider is the alignment of this integration with business strategies and goals. By clarifying these 2 points at the beginning stage of QC integration, we can ensure the organization does have the capability to integrate QC, and QC integration can also add value to the organization. The second phase is the architecture vision. The first thing that enterprise need to consider is the business segment prioritization. Enterprise need to understand which business segment that can gain the Company that gain its value mostly from its R&D can prioritize integrating QC into R&D department to accelerate the new product development. And the second is the timing of investment. From this table, we can understand that both early adopter and late adopter has their own benefit and risk. For example, early adopter can gain competitive edge because they are winning market share and also becoming the industry leader. But because there are still numerous uncertainties that hasn't been resolved, they will also face greater risks. On the other hand, late adopter will gain benefit from more established processes and hence lower risk, but they may miss early opportunities. Next, I will pass on to Sinta.
Thank you, Alvina. So next, I will discuss about the core layers of logarithm ADM. So here, I will discuss the key considerations when creating architectures in 3 different layers. The first one is the business layers. The first consideration is management strategy. As we can imagine, implementing quantum computing can be very expensive with lots of uncertainties. So getting buy-ins from stakeholders can be a problem. So by providing senior management training related to QC, can empower them to make informed decisions and eventually they make them support QC initiatives. The second one is organizational structure. Because QC is very specialized technology, it will require specialized talents. That's why organization needs to think about where can they get the experts, and then how do they manage it in the organization, and how the reporting line will look like. The second one is information system architecture. The GAF ADM have 2 different areas in this architecture, which is data and application. But both of them have the same problem, which is compatibility. As we know, quantum computing has very specific data encoding, which is qubits, and even the program itself needs to run in the very specific quantum computers. So the problem here is how organization can establish a seamless connection between quantum computing system and the entire other systems. So our research proposed hybrid data management and creating custom connectors as the solution to bridge those 2 systems. The last one is technology architecture. So the first consideration here is deployment model. As you can see here, on-premise provides flexibility in managing the infrastructure, but the problem is it has very high upfront costs and it requires specialized maintenance effort. For example, they require very specific cooling system for the hardware. So unless the organization have a very specific reason to implement on-prem, they can think about managed services that provide continuous improvement and support with pay-as-you-go cost structure, which is more desirable for organization. The last one is vendor selection. So because it's still new, so there are lack of industry standards on how to manage the infrastructure and stuff that could lead to vendor lock-in. Vendor lock-in is the condition where organizations have problem migrating their infrastructure from one vendor to another one. So to mitigate this issue, organizations can think and prioritize vendors that participate in open source development to mitigate this problem in the long run. Okay, I think enough for the architecture. Shini will talk about on how to implement it.
Now I'll talk about the implementation and migration strategies. It's mainly divided into 2 parts, which is before the implementation, which is the planning side, and the governance side during the implementation. Firstly, I will talk about the operational solution. After we have a good understanding of the architecture in the business, technology, and information systems, it's now the time to calculate all the gaps and requirements. And because QC is still emerging, we do suggest that enterprise can have a phased approach with often what we call as evolutionary strategic approach. And so in addition to the gaps and requirements, in this stage we also need to find the constraints because there might be interoperability issues that might arise. In this section as well, we need to start developing the architectural roadmap. This is very important because it will build the foundation of the migration planning that we will have in the future and also the governance. Next is migration planning. In migration planning, there's two things that we need to do. Firstly, we need to assess the migration viability because QC is still having a high error, so we need to know the readiness of the enterprise, whether they have the appropriate resources, whether they have the available hardware, or they have the appropriate expertise. They also companies also need to assess their risk assessments so that they can plan the mitigation earlier on in the plan. Next, the migration plan is what we need to do to build on the specific activities and the timeline based on the architectural roadmap. This is very important. You have like a clear idea and resources required, in what time to deliver for a timely implementation. And after we finish the implementation planning, we now move on to the implementation sites. And when we do during the implementation, we need to have a proper implementation governance. Firstly, we need to do implementation monitoring, and then we need to have a compliance assessment. In the implementation monitoring, it is important to assess the progress and objective delivery because it's still early. There's still high error for the QC implementation. So the key success is to have a governance effort to make sure that the implementation adheres to the agreed architectural roadmap, to the agreed SLA and OLA. Next is the compliance assessment. It is also because this QC implementation is a disturbing technology and can change the way organization works significantly. So one way to illustrate this is the complex nature of QC make it difficult to trace back the potential cause of a harmful mistake. And this might give transparency and accountability issues, which is the evidence of non-compliance. And in case of non-compliance, companies will hold liable to address these consequences. Thus, it's important to have a regular compliance assessment. This includes to assess it against the organizational standard, government regulation, and ISYS architecture and governance that exists in the company. Next, I will discuss more about the post-implementation phase.
Thank you, Shinji. And now I'll cover the architecture change management and the requirement management. So, in the architecture change management, enterprise needs to establish a framework to manage the architectural life cycle. And this is to ensure that they can meet evolving business requirements and technological trends. But Shinji previously mentioned about implementation monitoring. However, the difference in here is that the focus is more into monitoring the trend after that implementation. This is crucial because quantum computing evolves rapidly, so enterprise need mechanism to track its fast development, especially when it involves business strategy, cybersecurity, and the technology itself. And the second part is if there's a change in the architecture, enterprise need to specify requirements for that particular change. This will ensure a clear roles and responsibilities for all the stakeholders involved in that change. And finally, the requirement management. This is the repository for all the phases that we've talked about. The aim here is to ensure that all those phases remains aligned with the business objectives, particularly quantum computing, because there is no best practice yet. So the best thing we can do is to adapt over time. However, adaptive approach has its own problem, especially when decision at a later date might impact the decision at earlier date. To address this issue, an impact-based prioritization is important. This will ensure that enterprise can prioritize requirements that is the most valuable first. Through this way, they could also revise and revisit with the other phases that we've talked before. And this is the end of our presentation. Before we end the session, I would like to highlight some key points that we've discussed before. It is now crystal clear that the implementation of quantum computing in an enterprise using TOGAF ADM methodology needs adjustment with several key considerations as listed in this table, from the preliminary into the required management iteratively. And because of this consideration, enterprise need to thoughtfully plan, adapt, and iterate in order to reach QC's full potential for innovation and advancement purpose. However, our research only related to this and does not employ any specific case study. Therefore, further research is required, especially incorporating a real-world scenario along with all kind of implementation experiments. And that is our presentation today. We are from Group 35. Thank you very much for your attention.